There's some interesting questions and observations in the comments on the last video, so I'll address some of those, but I'll just show some of the features on the bow that are sort of interesting and maybe a tad worrying. So if that's the centre line, there's this knotty area near the grip. Should I fill that? Is the sapwood compromised there? This is the sort of thing where it's easy to get a pinch, because you've got knots going through at an angle which is potentially causing a weak point. You've got the central pith of the branch or log or whatever it was showing there. That was the bulky area that was a little bit too bulky, and I've eased off a bit, but you can see the potential for a pinch across there. Similarly, a lot of other knotty areas. Now with battery low lights going, so I'll change the battery and then we'll get it on the tiller and have a look. But there's another area with a knot coming through, which is why I was, wondering if it would get back to 31. So it's far from perfect, and you can see the discoloration. One of the questions was, is the grip stiff? I've heard comments before about, with a warbow the middle shouldn't move, the grip doesn't flex until right at the end. What they mean is you can't see the grip moving until near the end. It's not worked by some miraculous cam or some weird, thing like a compound bow. The force is there all the time, and the force is gradually increasing to full draw, so the movement will gradually increase to full draw. Just because you can't see it doesn't mean it's not there. If you look at anything, you look at a big circle, a huge arc. If you consider a tiny little bit of it, you can't see the curve. It's easy to see a big curve, it's hard to see a very small curve. That's why some people think the world's flat, because it's so big they can't see the curvature of it. Anyway, we'll do this little experiment. I think I've done it before and I think it works. We'll add a couple of verticals here, so as it moves that should amplify the movement effectively. So if we measure between those two verticals, 19 centimetres, but I hate centimetres, 190 millimetres. And as we flex the bow, we should see that. There, you can see them moving apart. It's showing more on the left one, but there, that's at 60 pounds. So you can see how that's sort of amplifying that movement for us. Let's see if I can simultaneously measure it and pull it. We have about 65 pounds, and it still looks relatively flat to the eye, because this area was slightly concave, so it made it look stiffer than it was. And if I measure across there now, there we're up at 200 millimetres. So yes, the handle's flexing, but we could do the same experiment moving those two spills out to the end to see if they move a similar amount at a similar draw weight. In fact, maybe we should do that. So that's 180 apart. Let's just bunny hop it across. There, right, I've bunny hopped that one across to there, and we're, I've got it just about the same, 190 mil. give it a heave ho to about where it was before. And it's the same. So interestingly, we could repeat that procedure and go all the way down the limb and see if the movement, the curvature for every section was the same. Well, that was fun, wasn't it, boys and girls? Bit of extra zoomage and centralisation. Get her higher in the frame. So I was pulling that about 65. That's looking quite sweet now. Yeah, that was 30. Right, now I've taken that to... That's 85 at 30, so we know it will reach 30-inch draw. It's just a matter of losing that odd £5, but that's easily done. Just give it a hard stir and a good talking to.